Hello students and welcome to this video. In this video we will solve question number 281 to 290 of permutations and combinations. The link to download the PDF will be in description, as well as at the end I will show you how you can download the books with the update information. So without further ado, let's get started. Question 281 says that a student is allowed to select at most n books. So at most n books from a collection of 2n plus 1 books. If the total number of ways in which he can select at least one book, so at most n and at least one is 63, find the value of n. So this problem will rely on binomial theorem. So you can skip this question because we have not covered binomial theorem yet. But if you know binomial theorem, you can solve this very easily. So at least we have to select one book, at most n books. So number of ways of selecting one book is 2n plus 1 C1. For two books it is 2n plus 1 C2, and for n books it would be 2n plus 1 Cn. So we add that. Now from binomial theorem we know that 2n plus 1 C0 plus 2n plus 1 C1 and so on up to 2n plus 1 C2n plus 1 is equal to 2 to the power 2n plus 1. But we know that NCR is equal to NCn minus R. Now, if you see this would be 1 and this last would be 1. So we write that 1, 1 and remaining we write as 2s. Okay, we have to go from 1 to n, and after that it will be n plus 1 to 2n. So both the sums would be equal, and we have taken that as 2s, and our value which we need is s. So we subtract 2 from this, okay, and divide 2 as well. Divide from 2 as well. No, we don't subtract, we first divide. So we get 1 plus s is equal to 2 to the power 2n, which will be 64 because our given number is 63. So 63 plus 1, 64. So n will be 3 because 2n will be 6. 2 to the power 6 is 64. Question 282 says that there are m bags which are numbered by m consecutive integers starting with the number k. So the bags would be numbered k, k plus 1, k plus 2, up to k plus m minus 1. Each bag contains as many different flowers as the number marked on the bag. A boy has to pick up k flowers from any of the bags. In how many different ways can he do it? So k flowers chosen from the first bag is kck. From the second bag it is k plus 1 ck. And from the mth bag it would be k plus m minus 1 ck. So total number of ways is sum of all this, which is we have let as s. Now we know that NCR is equal to NCn minus R. So we write S is equal to KC0 plus K plus 1 C1, so on up to plus K plus M minus 1 CK, Cm minus 1. Okay. Now you see here, this is written as M minus 1 here. And KCK is equal to KC0 and K plus 1 CK is K plus 1 C1. So we have this. So this will be equal to, we add these two, so we get K plus 1 C0. Okay, and we it should be 1 actually. K plus 1 C1, it's a typing mistake. And then K plus 1 C1 and so on we proceed. So we repeatedly apply this formula. NCR plus NCR plus 1 is equal to N plus 1 CR plus 1. And finally we will get K plus M C K plus 1. Question 283 says that how many committees of 11 persons can be made out of 50 persons if 3 particular persons are not to be included together? So total number of ways of selecting 11 persons out of 50 for forming the committee would be 50C11. We treat ABC as one person. Number of ways of choosing 11 when all three are part of the committee is 47C8 because they will be treated as one person. So our required answer is 50C11 minus 47C8. Question 284 says that there are M intermediate stations on a railway line between two places P and Q. In how many ways can the train stop at three of these intermediate stations, no two of which are consecutive? So we let S1, S2, S3 be three intermediate stations where the train stops. So we have a total of M intermediate stations. Okay. So the least number of stations is P, and we let A number of stations are here, and then S1, then B number of stations, then S2, then C, then S3, then D, then Q. Note that in this case, A would be greater than equal to 0, D would be greater than equal to 0, but B and C have to be greater than equal to 1. So we let A, B, C, B, D be the number of stations. So this we already talked about. Now we sum this A plus B plus C plus D plus S1 plus S2 plus S3. This will be equal to M. Now S1, S2, S3 are all one. They are individual stations. So this I have already explained. So number of stations is M minus 3. This should be 3 because S1, S2, S3 is 3. Okay. Why I have written M minus 2 when no two of the stations where train stops are consecutive? Now this should be certainly 3. Okay. Now number of ways of choosing 3 out of M minus 3. We have to stop at 3 intermediate stations. That would be M minus 3C3. Hang on, let me see. Okay. So A plus, this would be 1, 1, 2, and okay, the number of stations is equal to M minus 2. Why number of stations is M minus 2? Okay, I got it. So here B would be greater than equal to 1 and C would be greater than equal to 1. So we let X is equal to B minus 1 and C is also equal to some Y minus 1. And from there you follow. But still I think it is wrong. M minus 2 is wrong in that case as well. So we write B is equal to X minus 1 and C is equal to Y minus 1 so that it becomes greater than equal to 0. And then these 3 will be 3, S1, S2, S3 will be 3 and 2 minus 1s. So plus 1 and minus 1, it should be M minus 1. So I think it should be M minus 1. Please confirm if you find this problematic. Question 285 says that A is an n-element set. A subset of P of A is chosen. The set, a subset P of A is chosen. This of is a redundant. The set A is reconstructed by replacing the elements of P. Then a subset Q of A is chosen. Find the number of ways of choosing P and Q such that P intersection Q contains exactly 2 elements and P intersection Q is equal to 5. So we let A is equal to A1, A2 through An. For each element AI, there are 4 possibilities. AI belongs to P and also is in Q. AI is not in P and AI is in Q. AI is in P and not in Q. This symbol is improper. I will fix this symbol. And AI is in P. AI is not in P and not in Q. So when we now consider the case when intersection contains exactly 2 elements. We have to choose 2 elements out of n, that is NC 2 ways. Remaining n minus 2 elements, from remaining n minus 2 elements, we can choose one of 3 states, that is 3 to the power n minus 2 ways. Okay, so one of 3 states. So why it says one of P intersection Q is equal to 2. So the intersection will contain the elements only in this case. All right. So the remaining states are 3. So remaining n minus 2 elements can be chosen from 3 states. So n minus 2 elements have to satisfy either the second condition or third or fourth condition, but 2 elements will satisfy the first condition. The number of ways in which P intersection Q will contain exactly 2 elements is MC2 multiplied by 3 to the power n minus 2. Question B is, since P intersection Q is phi, all elements can choose one of the 3 states. Thus total number of ways is 3 to the power n. So in the second part, the element can be in this situation second or third or fourth, but cannot be in first situation. Question 286 is that A is an n element set. A subset P1 is chosen. The set A is reconstructed by replacing the elements of P1. Then a subset P2 is chosen, and again the set is reconstructed by replacing elements of P2. This way M subsets P1 through Pm are chosen where M greater than 1. Find number of ways of choosing these subsets such that union of all these subsets contain all elements of A except 1. The union of all subsets is equal to A. Intersection of all subsets is phi. So we let A1 through An be the elements of A. For element A1 and one subset P1, there are only two possibilities. A1 is either in P1 or A1 is in P. A1 is not in P1. So total number of ways for one element of A and one subset is 2. Number of ways in which A1 does not belong to P1 is 1. Okay. Total number of ways for A1 and M subsets will be 2 to the power m. So it is 2 to the power m. Total number of ways for A1 to belong to not belong to, okay, it not is missing here, to M subsets will be 1 to the power m, okay, because this is 1, this is 1 to the power I. So total number of ways for which A1 does not belong to M subsets for A1 does not, okay, sorry, my mistake, this is fine. So total number of ways for A1 to belong to subset is 1 to the power m, as well as not belonging is also 1 to the power m. Because if you pick either this case or this case, then it will be one way, and then for m subset it would be 1 to the power m. So intersection will be very simple. Intersection phi means one state that is not in P1, and that is 1 to the power m. Now A1 not in intersection would be A1 not in intersection would be 2 to the power m minus 1 to the power m. And A1 is element of P1 through Pm, unions of all these will be equal to 2 to the power m minus 1 to the power m. Now we have to choose one element out of n which has n ways. Remaining n minus 1 elements are in this subset, this union of subsets. So this would be 2 to the power m minus 1 to the power m to the power n minus 1. So total number of ways is n multiplied by 2 to the power m minus 1 to the power m multiplied by n minus 1. Now all n elements are in the union of subsets. The number of ways would be 2 to the power m minus 1 to the power m to the power n. All n elements are not in the subset of intersections would be 2 to the power m minus 1 to the power m to the power n. So it was somewhat involving problem. I hope that you have understood 286. So you need to know set theory for this. If you don't know set theory, it wouldn't work. Question 287 says that there are 3 sections in a question paper, each containing 5 questions. A candidate has to solve any 5 questions, choosing at least one from each section. So we have 3 sections, each will have 5 questions. Student have to solve 5 questions, choosing at least one from each section. Find the number of ways in which candidate can choose the questions. So we have following choices here: 311, 131, 113, or 221, 212, or 122, where the first digit represents the first paper, second the second, and third is the third paper. So we have 3 sections. So it represents sections, and total is 5 questions. So these many ways the student can answer. So for example, this choice, if you look at it, it would be 5C3 multiplied by 5C1 multiplied by 5C1 is equal to 250. But there are 3 such cases, so total number of choices would be 750. Similarly, for 212, it is 500, and there are 3 such sets, so it would be 1500. And therefore, total number of choices would be 2250. Question 288 says that two numbers are selected at random from 1 to 100 and are multiplied. Find the number of ways in which the two numbers can be selected so that product thus obtained is divisible by 3. So the product will be divisible by 3 if one of the numbers is divisible by 3. When one of the numbers is divisible by 3, we consider only one number to be divisible by 3. The number of ways, number of integers between 1 and 100 divisible by 3 is 33. The second number is not divisible by 3, so those are 67. So we multiply that, we get 2211. The second case is when both are divisible by 3. So total number of ways in this case would be 33C2 because there are 33 numbers divisible by 3. This is 528. Last total number of ways of selecting the numbers is 2739. Question 289 says that in how many ways can a mixed doubles game in tennis be arranged from 5 married couples if no husband and wife play in the same game? So number of ways of choosing 2 husbands is 5C2 10. After selecting 2 husbands, we have 3 wives to choose from. Number of ways of choosing 2 wives out of 3 is 3C2, that's 3. However, wives can part on either side, so total number of ways is 10 multiplied by 3 multiplied by 2 is equal to 60. Question 290 says that there are n concurrent lines and another line parallel to one of them. How many different triangles will be formed by the n plus 1 lines? So the line which is parallel to n, this is a single n, concurrent line has to be part of all triangles. Also, the line which is parallel to it will be part of no triangle. The total number of possible triangles is n minus 1 C2. So the line which is parallel is 1, okay? And the line parallel to that will not be part of any elements. So we choose this line is one side and the line parallel to it is the other side. Not other side, that won't be in the triangle. So we have n minus 1 lines and we have to pick 2 out of them, that is n minus 1 C2. So with this we come to the end of this video and I'll quickly show you how we can download the books. So you go to astavakra.org and you can download Algebra, Trigonometry and Coordinate Geometry. So the PDF link of Trigonometry and Algebra is in the description, will be in description, and Coordinate Geometry I will put it in description once conic sections is complete. So the advantage of downloading from a website is that you know what date it was modified on, and when you download you should add that date in the file name. I cannot put that date in the file name because if I put the date in file name, then all the YouTube links will become invalid. Okay, so that's why I cannot put it there. A bit of fair warning though, as you have known by now, if you have watched my playlist, then there are lots of typing mistakes. Sometimes there are calculation mistakes. So take that with a grain of salt and enjoy the book. Okay, I think it's quite reasonably good book. So with this, I will end this video. I hope that you have enjoyed the video and found it useful. So we will meet again tomorrow for 10 more problems, and till then I will keep my leave. So thanks again for watching the video and we will meet in the next one. Till then, keep practicing. Bye.